Next, we're going to do a very similar exploration to find the derivative of the cosine function. So now, our original function f of x is cosine x. And just like we did for the sine function here, we're going to go back to the definition of the derivative. So f prime of x equals the limit as h approaches 0, f of x plus h minus f of x over h. And so that's going to be limit as h approaches 0. And now it's cosine of x plus h minus cosine x all over h. Okay. Now, again, like we saw with the sine function, there is an identity to handle this first term. That is one of our angle addition identities from trig. And you commonly see that as like cosine A plus B equals cosine A cosine B minus sine A sine B. Okay, so we're going to be using that, but A corresponds to X, B corresponds to H. Okay, so let's expand that term out a little bit here. We're going to have cosine X cosine of H minus sine of X sine of H. Oops, and then I almost forgot again. We have a minus cosine X tagging on the end there. Minus cosine X. And then that's all over H. Okay, now notice we have a couple terms with a common factor again. The common factor is cosine X right here and right there. And so let's put those two guys together. Cosine X times cosine of H minus 1 minus sine X times sine H over H. Okay. And following that familiar pattern from the previous video, we're going to split this into two different fractions. Cosine X, cosine H minus 1 over H minus limit H approaches 0, sine X sine H over H. So I actually did two steps in one there. I split our single fraction into two different fractions. So this fraction and then minus this fraction. But then, you know, remember that if you're taking the limit of subtraction, you can take the limit of each term and subtract those limits. So I went ahead and applied this second limit right here on that second term. Okay. And that's going to help us out here because now we can look at limits as h approaches 0. Just like in the previous video, if a part of this expression doesn't have an h in it, like a multiplied factor that doesn't have h, like cosine x here, that term, that factor, doesn't really care as h approaches 0. It doesn't have an h in it. It's just got x. We can take it out of the limit because it is not going to be affected. So cosine x is just going to multiply this first limit here. Limit h approaches 0 of the remaining terms. Cosine of h minus 1 over h. Okay. And then the same type of thing is going to happen in our second fraction here, second rational expression with the sine x. That also doesn't have an h in it, so as h goes to 0, it doesn't care. We get to bring it out of the limit, since it is a nice multiplied factor that is unaffected as h approaches 0. So we end up with sine x times the limit as h approaches 0 of sine h over h. Now, these limits should look familiar from the previous video because they're the exact same limits. All right, the sine h over h, that's here. That's our nice result from section 2.4. This part equals 1. And then this limit here, limit as h approaches 0 of cosine h minus 1 over h. That is the exact same thing that was right up here. Okay, so that one we had explored numerically using a calculator, picking very, very small values of h, and that limit approaches 0. So no need to reinvent the wheel there. We can put in the results that we previously found. And we'll end up with cosine x times 0 minus sine x times 1. And that first term is going to disappear on us, leaving us with that negative, okay, that's still there, minus sine x. Okay, so our result is negative sine x. That is our derivative function. F prime of x equals negative sine x. For the original function, f of x equals cosine x. Okay, so that is our second big trig derivative here. Derivative of cosine is negative sine. Let's go up to our table and put that in. Negative sine of x.